So let's start. And the question of today is, can Kotlin Swift Interop ever be perfect? The answer is no. But why though? If that's all you wanted to know, you're basically free to go. If not, let's talk about why. Let's talk about the challenges language interop puts behind, whatever, for us, and how do we approach them in doing Kotlin native Swift export. My name is Gleb. I work in Kotlin native team at JetBrains. So let's start. The first why I should address is probably why I'm making this talk, right? You see, I always have the same argument with different people over and over and again. They approach me and say, hey, what are you guys doing? It's basically the same language. You just convert like val to let, fun to func. We converted like entire code bases in just a weekend. What are you guys doing there? Yeah. So let's answer that. First point is, we are not a transpiler. We are not converted any code. We don't have any code. We're actually a bridge technology. What does it mean? You see, we take all your Kotlin code and we compile it normally with Kotlin native as a Kotlin native library. We leverage all the work the guys do there for us, all the compiler optimizations, everything. That's really nice. Yep, that's that purple square. And we also don't want to touch any Swift. We don't want to repeat any work that Swift compiler does for us, hell no. So we also delegate that to the Swift C, right? What are we is that little arrow. We are the bridge. We do a bit of this, a bit of that, generate a bit of Kotlin, a bit of Swift, we intermix them, and boom, your Swift code is talking to Kotlin code, and vice versa. Throughout the talk, I will be using those pareidolia induced shapes for showing which language I'm talking about. So please pay attention, right? So what's the challenge? Okay, sure, we're not a transpiler, but what's the challenge in that little black arrow? Let's see. Well, news are the languages are actually different. They use completely different approach to like everything but the syntax. So the primitive types are different, despite they have like the same meaning, void and unit. Unit is actually like a singleton type, a reference, while in Swift is basically a zero-size tuple, any zero-size tuple. Even ints are different sizes. In Kotlin it's 4 bytes, and in Swift it's a machine word. It's almost always 64 now. And even optionals, like simple fundamental thing, we also approach differently. In Kotlin, nullable type, nullable is nullable reference, is just a null. That is just a reference, which is sometimes a null. In Swift, optionals are structural. They have like complex representation. You can nest them. So even there is a problem. And we handle everything that for you. When you call into Kotlin from Swift, we just detect everything and convert everything. So everything fine. But wait, what do you mean you can call into Kotlin from Swift? You cannot. It's different languages. They use different calling conventions. Their functions talk differently at binary level. So we also do a little bit of ugly thing. We create special Kotlin code that pretends to be C. It follows C calling convention, and Swift can work with C, which is really nice. But C, well, let's put it like that, is a classic language, so it doesn't have much of anything. So we basically have to map exceptions for you. We convert them to errors as a Swift side so you can handle them. And we can carry out asynchrony. We do that little dance with suspending current context and passing continuation and resuming it and resuming that context and yada yada. So that also handled. You don't have to think anything about that. Except the problem doesn't stop there. The memory models are different, so even after you can call into Kotlin from Swift and can pass primitives, they are completely different languages with different memory models. Swift uses what they call automatic reference counting, which is basically a fancy name for the fact that in Swift, every managed pointer is basically a smart pointer, like it's C++, or like ARC in Rust, if you're familiar. In Kotlin, we have fully fledged garbage collection. And what we have to do to make this work is basically we teach our garbage collection to work with automatic reference counting. Like we have counted references specially handled for our garbage collection. We won't give them to you, it's just for us, so just saying. And there are also value types. And we even handle that mismatch because in Swift, not everything is an object, but in Kotlin, it's basically everything is an object, so you get me. Okay, and that's not it. All, I mean, not everything. Everything is different, actually. Overriding rules are different, so we basically have to recreate them. And that interacts with subtyping, which is also different, which we also handle. Kotlin has that fancy features, which Swift just doesn't have, like context and extension receiver parameters, which we tag in some places in functions. The Swift has like completely different notion of the module, and we kind of don't have a notion of the module, at least not a single understanding of it. And we handle that, we generate enums on the Swift side that mimic package structure, fascinating stuff. You can learn about everything. We handle everything for you. And you can learn about that in my colleague's talk from the last Kotlin Conf. Please refer to that. It's not a matter for us today. Because today we are not talking about what we can do. We are talking about what we cannot. Because sometimes you just cannot win at all, right? Let's talk about 3 examples. First one will be generics. Well, it actually should be called a polymorphism, and how different kinds of polymorphism can collide in Swift and Kotlin, but let's see. Let's talk about generics. What do we want to have? For example, you have like generic type T, and we want that to appear as a generic type T, I mean, foo, right? Completely different languages, by the way. You wouldn't be confused, like any day. What we do not want is to erase types. That's what we have today, unfortunately, but that's a like intermediate measure, like temporary. What we also don't want, like definitely don't want, is to implement them completely different, like bridge Kotlin classes to Objective-C classes, for example, which behave differently in Swift. So, right, I hope we agree there. So, what's the issue? Let's talk about how each of those are implemented in either of those languages. In Kotlin, generics are, well, based on type erasure, which means that compile checks everything at compile time, and at runtime, no generics exist. Everything is just a reference, right? Because Kotlin can afford that. It uses just everything as an object, and it uses like pointer for basic value polymorphism. But in Swift, it's kind of a bit more complex. In Swift, every generic is reified. That means that each object of generic type remembers the types it was instantiated with. Well, it leads to the problems immediately. For example, it has like dire complications for wrapper object caching and how you compare stuff. For example, well, you see Swift sees 2 generic types, one generic type specialized with different generic arguments as 2 completely separate types, and even instances of those types are completely separate, which means you cannot cast between them. Those would be like generic variants, which we have in Kotlin, but in Swift, we do not. I mean, if you were a standard library developer, because in Swift, like the standard library collections do have generic variants, but well, we do not. So Swift thinks. So this already forces us to do some ugly hacking and probably introduce some kind of specific casks. I mean artificial, because you cannot cask like that, right? So there probably will be some functions for ugly functions for casting between types in Swift. But that's not the issue, actually, I wanted to talk about. Is this. This is a pretty simple Kotlin idiom. It's some code that you can encounter in every code base. We have an interface. We have a generic type, which with an argument constrained to that interface. And we use that interface to, well, supplement a type when instantiating it. In Swift, you would want to see that. Again, completely separate, like nothing to confuse about. Well, protocol is just Swift lingo for interfaces. What the only meaningful difference here is that any variable. In Swift, you cannot use the protocol as a type. Existential of a protocol is a type, which is marked with any. You don't always have to put any, but you always can, so it's always there. So yeah. Well, and this sounds fine, right? But it is not. You see in Swift, existentials of protocol types do not conform to their own protocols. Well, because protocols can have static members and yada yada. I don't want to hear about issues. I just want to show this. A very simple and very prevalent Kotlin pattern generates so much problems in Swift already. What it will force us to do is to replace any variable with some kind of our custom existential type, which is not actually existential, but some just artificial type, and force users cast to into it and from it, and it will be ugly. So yeah, it will be ugly. Let's talk about closures. Closures are a bit more pleasant topics. They're not so complex, and they are closures. And okay, we love closures, right? So what do we have in Kotlin? We have a simple function that maps a closure. It receives a closure and returns a closure. What we do want to see in Swift is a function that does the same. What we do not want is any artificial type that would require wrapping into it or casting from it manually. And we also don't want to bring any Kotlinisms in it, like nothing a Swift developer wouldn't be familiar with. So let's see how they are implemented. In Swift, a closure is basically a pair of two pointer types. And in Kotlin, it's basically an anonymous object implemented in a functional interface. What does it mean? It's one cannot be another. That's just the only thing here we should note. Another thing to note that will be interacting directly with that is that in Kotlin, anything is cacheable. And the Swift, well, nothing is cacheable. Well, actually, nothing is cacheable, which is called never. But any is not hashable. What hashable are nominal types explicitly conforming hashable. You don't know what nominal types are? For the purpose of the talk, they are not lambdas. They are anything but lambdas. So, well, lambdas are not hashable. And any hashable, well, 5 things. So why does it matter? You see, if you have a Kotlin lambda and you want to pass it to Swift, we have to wrap it because one cannot be another, right? So we make a simple Swift closure that does a little dance and calls into Kotlin. And if you want to pass it back, we have to wrap it again. Because, well, Swift doesn't give us any instrument to peek into closure and see what's there and unwrap it. Yeah, so we can kind of have wrap it back. And those two will not be equal, will never be equal. And if you repeat the process 2 times, like 2 times, you get 2 closures, and they also won't be equal. Why does that matter, you may ask? Because this, I present to you every other callback registration API out there. If you pass a lambda once to register it, and when you pass a lambda again to unregister it, it won't be the same lambda on the Kotlin side. So basically, we want closures, but they're not hashable. Well, and we lose closure identity. But yeah, there are APIs that require closure identity. Checkmate. We cannot have both things. We have to sacrifice something. Okay. Let's talk about something simple. Closures are kind of complex. Let's talk about something very simple. Default arguments. Well, what do you want? Imagine we have like simple function with default arguments. We want to see some default arguments on the Kotlin side. What we do not want is to alter function signature. What we also do not want is to generate overloads. Why overloads? Because this. A simple standard library function that will have 6 defaulted arguments, which gives us, without juxtaposition, without reordering, is 2 to the power of 6, which is like 16, 32, 64. 64 overloads. Nah, not doing that. No. Okay, so what can we do? In Kotlin, the default arguments implemented via bitmask. And in Swift, Swift generates like a simple satellite function that produce default values, which already means two languages optimized for different things. Swift for API and ABI stability, while Kotlin for, well, flexibility, I guess. Let's see like in a bit example. Like in Swift, two satellite functions, and when you call it, the compiler uses it, right? And in Kotlin, if you define a function, the satellite function, like another function, and when you call it, the compiler call actually that and provide a bit mask. So there are two possible approaches here. One is to generate a bit mask on the Swift side somehow through those satellite functions. Unfortunately, we cannot do that because, well, there can be suspension points, there are threading issues, there is nowhere to put it, nowhere to pass it. It's kind of very iffy, very iffy. And if you were to go that way, it will be super hacky, it's probably very fragile. Another approach would be to, well, have Kotlin default values as Swift default values, like directly translate them. Well, the issue is that analysis API doesn't give that to us. Well, I can go over to the guys from analysis API and ask them really nice to surface default arguments, and they will hate me. I will probably be the most hated person in that corner of the office, but, well, sacrifices, right? And that might just work. Except Kotlin has this little nifty feature. You can actually reference this and preceding arguments from default arguments expressions. And in Swift, you just can't. So yeah, sometimes you just can't have nice things. You just saw 3 examples. One requires us to make things really ugly. Another requires us to sacrifice things and choose. And the third one just has no clear pathway forward. Well, as was somebody said, sometimes if something looks suboptimal, it probably optimizes for something you can see. And that's precisely the case for us. Sometimes we just cannot do that perfectly. What that means, well, I hope I gained some understanding from you today, but what it also means is that you should engage. Please come over to me, distract me from everything I do, and speak your mind. Find me here in the conference, or reach us through Slack, or create your track issues. We really need your ideas and your feedback. Maybe we can do something better. Maybe we can sacrifice something over another. Anything works. Please, guys, until we go to beta, because that will be late. Thank you.